Hi guys. So today's the second day of finding the volume of a region rotated about the x-axis. Okay, so here are two practice AP questions. See if you can take like 4 minutes, right? 2 minutes each, and see what you can do with them. So in the number 12, we're not actually solving it. They just want you to do the u substitution, right? So if u is the square root of x, that means du is the derivative of x, 1 over 2 root x dx, which means dx is 2 root x du. So when I make my substitution, e to the u over, now do not replace the square root of x because we need it to cancel out with the derivative of dx. So those cancel. So we get the integral of 2 e to the u du. So it's not d, right? It's not e. So it's one of those three. Now let's look at our bounds for a second. Now remember that these are x values. So if we plug in 1, what do we get? The square root of 1 is 1. So the bottom is a 1, right? Now plug in 4. The square root of 4 is 2. So the top number has to be a 2. So the answer is C. All right, these are the ones that kids always mess up. You get good at them for like a day and then they fall out of your brain. All right, so for F, remember our point is 0, 1. So that means its inverse has the point 1, 0 on it. Because it says G is an inverse of F. So now we're going to find F prime of X because we want the derivative. That's 3, 2x plus 1 squared times the derivative of the inside. So that's 6, 2x plus 1 squared. Now, we're going to plug into this. Now, if you look at the F is there. The x value is 0. So we're plugging in 0. We get 6, which means if the slope is 6 here, the slope of its inverse is 1 over 6, the reciprocal. Not the negative reciprocal, just the reciprocal. So the answer is D. All right. Find the volume of the solid generated by revolving the region bounded by the graph y equals e to the x-axis, and the lines x equals -2 and x equals 2. So this is pretty much the most basic type. So think about, what does e to the negative x look like? That's e to the negative x from -2 to 2. So there's my region. Now that's getting rotated, so it kind of gets rotated down. A good way to do it is to kind of draw the reflection, and then it's going to be rotated around. So it's kind of this cylindrical thing. It's like a cone with the bottom cut off on the side. So I don't have good pictures of this one, I'm sorry. So that's what it looks like. It's flat up against the x-axis, so there's no subtraction or anything. So remember, it's the area of a circle. So pi r squared, and from -2 to 2. Now, what are we integrating? Well, what is the radius of the circle? What is that distance? That distance is just the function, e to the -x. Okay, my arm is like in a weird spot, so I'm writing terribly. Okay, so all right, so we're going to simplify this. So pi -2 to 2, e to the -2x dx. So this is technically a u substitution. You can either do a u substitution or just remember that you have to divide by the derivative of your exponent, so -2. I'm just going to divide. So I've got my pi, the antiderivative of e -2x divided by -2 from -2 to 2. So I'm going to pull out my constant. So negative pi over 2 times, plug in 2 e to the negative 4 minus e to the 4th. And that's your answer. I don't feel like simplifying it. I mean, there's not much you can do there, so you're done. All right, so here's our definition again. So the whole idea here is when you have two functions, right? There's our function, there's our area. When we're rotating about, like when there's a gap between the axis of rotation and the curve, when it's rotated, there's this gap here, right? So there's a hole in the center of this solid that you're creating. And depending on when you watch this, I'm going to show you a video of this. This is not a terrible picture I'm drawing. So it's just like this weird cylinder with like a imagine toilet paper, right? So it's you're finding the volume of just the toilet paper, not the hole in the middle. And the key here is if this is your axis of rotation, this is your f of x. You have your big R minus your little r, the distance from the axis of rotation to like the center. That's your little r. So the key with these, the hardest part, is identifying big R and little r. All right, so find the volume of the solid of revolution generated by revolving the region bounded by the graphs of y equals 2 over x and y equals 3 minus x about the x-axis. So we have 2 over x equals 3 minus x. We need to find where those intersect because they're not giving us bounds. So 2 equals 3x minus x squared minus 3x plus 2, x minus 1, x minus 2. So those are going to be our bounds. Right? So when I integrate pi from 1 to 2. All right, let's get a view of this thing now. So 2 over x, that's a general function, right? And then I've made that too far away. And then there's 3 minus x, so there's 1 and 2. So this thing is being revolved, and so it's creating this weird shape. It's kind of like a cone, or a funnel. It's kind of like a funnel. Yeah. So again, like I said before, my axis of rotation is the x-axis. So from here to the farthest function, which function is farthest away? Well, that's your line, right? That's the line. So that first function is 3 minus x squared. Minus the other function is the one that's closer to the axis. That's not a good color. Maybe I'll try green. So that function, which is your 2 over x. So now we can do this without a calculator. I'm going to integrate from 1 to 2. I left this as 3 minus x. You could also multiply it out. Oops. However, you do need to multiply out 4 over x squared. Antiderivative, so pi times, so I did 3 minus x cubed over negative 3. Now you have to divide by a negative because that negative on the inside. We're dividing by the derivative of the inside. Plus 4 over x from 1 to 2. I'm just going to tell you the answer because this was obnoxious to do. The answer was, where is it? Pi over 3. So you can take your time, go through, plug in. It's a lot of obnoxious algebra that we're just, or not even algebra, calculation. But the answer is pi over 3. That's an ugly pi. I'm going to fix that. All right. It's really the setup. Like once you get here, that's like the important part. All right. So this is from the AP exam from 2001. So funny fact, this question was on my exam. I took the AP calculus test in 2001. So this is the problem that I did not do well on, clearly, since I did not pass the AP exam. But you guys are way cooler than me and smarter than me, so you're going to pass. I have confidence. All right, so we actually did A and B last week. So let's just do the setup, the integral, the area of R. So you have an option. You can do this in terms of y, so yet you only have to do from 0 to 1.2657, or you can do it in terms of x, and then you do 0 to the 0.9, and then the 0.9 to whatever this point is. So we can set both of those up. If I do it in terms of x, let's call this A and this B, and the AP people are good with that. So I'm going to integrate from 0 to A, this point, of this function, so that's tan, plus A2. Now we need to figure out what's this point. Well, this is the 0 of this function. So if you solve that, you get the cubed root of 2. So the cubed root of 2 minus x cubed dx. Or you can do the integral from 0 to b, the y value, right minus left. So that's 2, whoops, I have to solve this. Not 2. So if I take this function, 2 minus x cubed equals y, and solve for x, I get x cubed equals 2 minus y. X is the cubed root of 2 minus y. Cubed root of 2 minus y minus my right function, so that's tan, so that would be inverse tan. Either way, you get the same answer. So those are your two options for part A. All right, part B. Find the area of S. Now this one's the easier one because it's already in terms of x. There's no breaking it up into pieces. Top minus bottom. The integral from 0 to A. My top function is 2 minus x cubed. My bottom function is tan x dx. So that's the area of S. Now, the nice thing about B is it really helps you for C. So C is the new stuff. I'll do C up here. Okay. Find the volume when S is revolved about the x-axis. So the integration, so it's pi, just like the area, it's 0 to A. But now here's the thing. I'm going to erase this. We need our big R and our little r. From the x-axis, which function is farthest away? Well, that's the 2 minus x cubed. So 2 minus x cubed, remember we're squaring that, r squared, minus little r squared to the closer function, tan squared of x. That was like super ugly. I'm sorry, guys. Equals, and now we are not doing this by hand. You might be able. I would not do this by hand. Put it in the calculator. 8.332, and we're done. All right, so here's the answer key. So if you notice, again, they did give you. There's actually, when I looked at the answer key, they give you 3 methods to find the area. Just pick one, whatever you want. So I did both of those. And then the area for S. Now notice, okay, they did this one in 2 ways, in terms of X and in terms of Y, but the terms of X is easier. For part C, the new one, so we got our answer, 8.332. They also gave the answer as 2.652 pi. I leave it like that sometimes. It's just kind of based on my mood. Do I feel like multiplying by 3.14? The pi button or not. But there's not like any, it's whatever you feel like doing. There's no real reasons for either. I love these problems. Look, limits get you a point. The integrand, the inside gets you a point, and then a point for the answer. So I love these. They're not overly hard once you get the hang of them. And the answers, and lots of partial credit if you make a silly mistake. What was my problem when I was 17? I don't know. All right, sorry, the homework looks weird because I accidentally assigned a bunch of problems that I assigned yesterday. So, homework 11, 14, 33, 53, and I drew a generic AP student who clearly is going to get a 5 on their AP exam. Come on, 45 minutes, guys. We can do it. All right, I'll see you tomorrow. Bye.